Amides can undergo what we call a hydrolysis reaction. When they do this reaction, they will reverse the formation of the amide. It will give you back your carboxylic acid, and you will get your amine back as well. So what's going to happen? The reagents of water and HCl along with heat will perform a hydrolysis reaction. This is an acidic hydrolysis reaction. And when you have an acidic hydrolysis reaction, you will reform the carboxylic acid plus the amine or whatever nitrogen group was attached. In this case, it's not an amine that was attached. We used ammonia to make this amide. And so we're going to kick off NH3. So if you remember, to make an amide, you have to have the nitrogen lose a hydrogen. In this process, it gains back its hydrogen. It leaves and is no longer attached to the carbonyl. And we reform our carboxylic acid in this process. There's a second type of hydrolysis, and it's under base conditions. And it does a very similar thing, except it doesn't reform the carboxylic acid directly. It will form the carboxylate, since we know from previous chapter when the carboxylic acid is in the presence of a base, it will be deprotonated and have that negative charge on the oxygen. So what's going to happen is you will reform this carbonyl. It'll start to reform the carboxylic acid, but the base will deprotonate it and it'll form the carboxylate. The two reagents that do this, we will need water and sodium hydroxide, some sort of base, and again, heat is used. So we form the carboxylate ion, and then we're going to remove the amine. And remember, when we remove the amine, we replace or put back on one of those hydrogens that was lost when we formed the amide, and the rest of the molecule will stay the same. And these are the two products we get from a base hydrolysis. So when you do an acid hydrolysis, you form the carboxylic acid, as shown right there in that functional group. And when you do the base hydrolysis of the amide, you get the carboxylate